Hello, everybody. Welcome to the 7th R Help video for homework 7 STA 371G. Today I'll be going over showing more decimal places, finding the critical value, finding the p-value using the test statistic, removing rows, making a multiple regression model, creating new columns based on old columns, using the confident function to find the confidence interval for coefficients, and finding the BIF using the CAR package. So first, to get more decimal places in R, do options, parenthesis, digits equals, and then however many digits you want it to show. This is helpful because sometimes for your homework assignments, you'll have to show a certain number of decimal places, and by expanding it to 12, you can make sure you show enough places. Next, to find the critical value, you'll need your confidence level and your degrees of freedom. You can create vectors with the confidence level and degrees of freedom to make it easier, so then you can just copy and paste your critical value command. Critical value is equal to QT. The first number is 1 minus the quantity of 1 minus the confidence level divided by 2, comma, degrees of freedom. So once you've put in your confidence level in DF, you'll simply run it and get your critical value. In this case, it's about 2.05. Next, to get your p-value, you'll do 1 minus the pt function, test statistic, degrees of freedom. In this homework assignment, your test statistic will be given in the problem, so make sure you're using the relevant test statistic for whatever p-value you're trying to find. You can do the same thing and create a vector, and then simply copy and paste this function. Remember, you'll need to run your degrees of freedom. I've already run it, so I do not need to retype it. Once you run this, you have your p-value. Here it's 0.48. Next, let's say you want to remove rows, as you will have to do in one of the homework problems. To do this, type the name of your data set. It doesn't have to be data. It could be data Q1, Q2, etc. Open bracket, C, the rows you want to remove. Note this will remove the entire rows. Put it in parentheses, comma, in bracket, equals NA. So it will change rows 6, 9, and 24 to NA. So let's look at the data. Right now we have data in 6, 9, and 24. If we open the script and we run the command, we can go back to look at our data. And now we do not have data in the entire row because we told R to take it out. Next, to make a multiple regression model, use this format. Model name equals LM data $y tilde data $x plus data $x2 plus data $x3. You'll notice this is very similar to making a single regression model. Alternatively, you could always use model equals LM, similar to the single regression model as well, x1 plus x2 plus x3 data equals data. Remember, you'll want to do it this way if you plan to use the predict function in the future, but you could do it this way if you prefer. An example of doing this is, let's say we want to predict healthcare expenditures, RY, from the internet users per 100 people and the expected schooling in years. To do so, I simply followed the format. I have in mind 30, and I ran the model. Once you run it, it should appear in the top right. Make sure you run it before you try to find the parameters. If we type model, we can get our intercept and our coefficients. You can also do summary model to get your intercept coefficients, in addition to a lot more information like the standard error, t-value, p-value, your p-value for your model, r-squared, f statistic, etc. So it's more helpful to use the summary function if you need all this information, but if you just need coefficients, you can run model so you don't get mixed up between all the numbers. To create a new column, you'll use the format new column equals data with the old column with the modification. So what I mean by this is, if you want to create a new column that holds the square valued, type your new column name equals your old column and then modify it with the square. To create a column with data squared, you can do it this way. So let's say we had schooling in our model, but we want a new column with schooling squared because we think it will be a better predictor. So we can run this command, and then now we have a vector for the schooling squared. So now let's say we want to add it to our data. We can simply type data $ schooling squared, assuming this is our data set. And if we look at the data, we'll now have a column with schooling squared. Notice you don't always need to add it to your data set. If you do, it will appear there, but if you just plan to manipulate it and then use it as a vector, you can leave it without adding a column. Now, it's the same concept if you want to multiply by a fixed number for some type of conversion, as you'll have to do in the homework. So you'll have your updated column equals whatever your conversion factor is. I just chose 5 arbitrarily, times whatever you want it to be. So let's say for some reason we think 5 times the expected schooling will be good to have. So then we can run this command, and we'll now have an updated column with all the numbers for the 5 times schooling in years. Notice it's the same concept here. If you do this, it just creates the object, but if you type data $ updated column, it will add it to the data set as we did for the schooling squared. So make sure you're doing what you want to with that. To create a confidence interval for coefficients, use the confind function with your model. Remember, you'll have to run your model first. I'm using the same model that I created up here. You'll then say conf.level equals 0.95 if it is a 95% confidence interval. It defaults to 95, so you could always omit that and you will get the same results. But it may be helpful to type it just in case it's not a 95% confidence interval in the future and you want to ensure that you do not forget to include the correct confidence level. Next, you'll need to use the VIF function. To do this, you'll need to install a package called car. To install a package, which you'll only have to do once. I'm not going to run this line because I have it installed, but let's say you don't. Type install.packages, open parenthesis, quotation, car, close parenthesis. This format will be the same for any package you need in R in the future. So once you have this, you can enter any package in here. Just make sure you have the quotations because you need them to run it. Once you've already installed the package, like I've done, just run library car. It's helpful to run this command anytime you close R and open it up again. So whatever R instance you're using has the car package, it will say loading. And when you install it, a lot of things will come up here probably. That's fine. It's just giving R the tools it needs for the package. So I have my package. Now, if you want to find the VIF, you'll run the VIF command and then the name of your model. So make sure you're not typing model, you're typing whatever your model is actually called earlier. Again, don't forget to run it. It won't work if you just have a line creating your model. And without running it, you need to run it to make sure it's appearing in your global environment or this won't work. Then we can run it and we get the VIF for our coefficients or for our x variables. So I hope this was helpful. Thank you for watching.